Right, so this session we're going to do Venn diagrams and universal sets. So Venn diagrams. Now what is a Venn diagram? A Venn diagram is basically how you represent sets within the universal set, right? So Venn diagrams are drawn with a rectangle being representing the universal set and circles that represent the subsets within the universal set. So if we go with this definition here, a Venn diagram can be represented using a rectangle to represent the universal set and circles inside the rectangle to represent a subset, right? And from the video before, we know what a universal set is. The universal set is the set from which all other elements are taken, right, or derived from. Now, we have three figures here, figure 1, figure 2, and figure 3. Now, if we were to draw figure 1, right, and we have two circles. What does this mean? Now, anytime you're drawing a Venn diagram, there's some things you have to do. Yes, you draw your rectangle. Yes, you draw your circles. But you always labels your sets. So this is universal set, and the universal set symbol is usually on the outside, not the inside, like we see in here. All right, and then label the sets. So this will be N, this will be F. So we have two sets, N and F. What does this mean? The shaded area, right? So the Venn diagram in figure 1 is used when two subsets have common elements, right? So common elements in the sets N and F. And from the first video, right, we know that when we have common elements, we use a symbol, so N, and the symbol for common elements or intersection is this upside down U, right? So the shaded area would represent this set, N intersect F. The second figure where we have two sets, set A and set B, right? But they don't intersect, right? So again, universal set, this is A and this is B, right? So they do not intersect. The middle here do not intersect. So this diagram, this is called a disjoint set. And what are disjoint sets? Disjoint sets are sets that do not, oh, that handwriting looking bad, I'll fix it, do not have common elements. So if you have two sets and they have nothing in common, you just draw them separate from each other. And the last one, where you see a circle within a circle, it is not inception, it's called subsets. So I put one in red, I put the larger one in red. And then I'll put the other one in black. Right, so again, the universal set is called a set A and set B, right? Since B is within A, we call B a subset of A. So B is a subset of A. So in this case, A is a larger set and B is a smaller set. So B is a subset of A. Now what the diagram means and what does the subset mean is that all the elements of B are contained in the set A. And this all should have been in capital letters. So it's all the elements of B are contained in the set A. Not some, but all of them. Right? The one, if you have some, it would not be a subset, but it would be an intersection. Right? So in this exercise, the information below, use the information below to answer the questions. So given the universal set, so they give us the universal set. And I say the universal set is 11, 12, dot, dot, dot. So what that means is the continuous, right? So 13, 14, 15. You don't have to write it out. You could use the dot, 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 18, right? And two subsets. We have A is in numbers divisible by 3. And what would be the numbers of the universal set divisible by 3? It would be 12, 15, and 18. And the set B would be odd numbers. And odd numbers are the numbers that cannot be divided by 2. So 11, 13, 15, 17. Now we can see off the back foot that we have one common element, and the common element in this case is 15, right? So from the previous diagrams, right, we would use the one that has the intersection because we have a common element, right, which is figure 1. So if they ask us to draw this as is, it will be figure 1. So what they ask us to do is to answer the questions. They want us to find what is A prime. Now, A prime, what is A prime? A prime is all the elements that are not contained in A. So what are the elements not in A? So we have, from the universal set, we have 11, 13, 14, 16, and 17. Question 2, they want B prime. Right? It's not supposed to have 2 dashes, it should be 1 dash. Right? So B prime is all the elements that are not contained in B. And what are not contained in B? We have 12, 14, 16, and 18. Number 3, we want A prime union B prime. And this is the union of two sets, meaning you combine the two sets. So we're going to write A prime and B prime combined. So we will have 11, 12, 13, 14, 16, 17, and 18. It is also okay if you do this. 11, 13, 14, 16, 17, and you didn't use 12, so you put 12 here. You have 14 already, you have 16 already, and you have 18, right? It's also okay if you do that. But putting it in order is usually showing that you understand what you're doing. Let me zoom out a little bit so we'll see the top questions. So number 4, we want A prime intersect B prime. And what are the common elements between A prime and B prime? The common elements would be 14 and 16. So the common elements in A prime and B prime is 14 and 16. Number 5, they want A union B. And A is not A prime and B is not B prime. So that's the two original subsets we have, right? So we could put them in the ascending order one time. The smallest number is 11. Then we have 12. Then we have 13. Then we have 15, 17, and 18. Right, that's coming from these two up here. Number 6, you want A union B in a bracket prime. So what does that mean? This means, you see, they want the elements that are not contained in A union B, and A union B is these elements here. So what are the elements not contained from the universal set? So we have 11, 12, 13, we do not have 14, so 14 is not contained, right? And 16 is not contained. And this is coming from the universal set. What you could do sometimes, if you need to cross out things, you could keep writing it in a corner somewhere. 15, 16, 17, 18, right? And when you want things on the outside, you just cross out what you have. So you have 11, 12, 13, 15, 17, 18, 15, 17, 18. And the ones that you have remaining will be the ones that are outside the set. That's one way of doing it, right? Right, number 7, we have A intersect B prime. Now, A intersect B in brackets prime. But we don't have what is A intersect B. So we need to find out what is A intersect B. So A intersect B will be the common element between A and B, and in this case is 15. So that means if we cross 15 out of the universal set, we'll have to write all the other elements. So 11, 12, 13, 14, we're not using 15, 16, 17, and 18. And let me bring everything to one side here again. All right, so number 8 now, you want the elements in A only. Now, A only will be the elements in A that are not common with B or any other set. Right, but we only have A and B, so the elements in A only, we minus in the common element. So in this case, we will take off the 15 and we will only have 12. So this is A only, and I should write A only. So we'll have 12 and 18. And number 9, they want B only, and it is similar. We do not write the common element, and the common element is 15, so we do not write it. So 11, 13, and 17. Number 10, we have A intersect B prime. Now this is the A, and this is B prime. So what are the common elements between here and here? The common elements 12 and 18. So you'll write 12 and 18. So 12 and 18. Number 11, A prime or A composite intersect B, right? And again, now this is the A composite set, 11, 13, 14, 16, and 17, and B is 11, 13, 15, and 17. So the common elements in that case would be 11, 13, and 17. Right, so remember the intersection, the upside down U is common elements. And 12, N, B. This N stands for the number of elements in the set B, and the set B is 11, 13, 15, and 17, so we have 4 elements. So you write 4. Number 13, you want the number of elements in the set A composite, and the A composite is 11, 13, 14, 16, and 17, So we have 5 elements in this case. And the last thing they want us to write is A intersect B, which we had done in the previous question, and we know it to be 15, right? And 15 now, they want us to draw the Venn diagram. Right, so the last one, number 15, they want us to write or draw, sorry, the Venn diagram. Remember, the first thing you have to do is draw a rectangle, and you have to draw 2 circles. Now, because we know A and B have an intersection, right? We have to draw the circles intersecting or overlapping each other, right? Then we say universal set is here. Let's call this A and call this B. The common element, you write in the middle here, so 15. Now when you set A, you'll have 12 and 18 remaining. When you set B, you'll have 11, 13, and 17 remaining. But we do not have all the elements from the universal set. So we have to write what elements are missing on the outside, right? So what elements we missing? So we have 11, 12, 13. We do not have 14. So we write 14. We have 15. We don't have 16, right? And we have 17, 18. And that's all the numbers. So the numbers in the middle here is the common elements between A and B. Would likely shade this, right? Should not have done it like that. I shade it like this, right? This will be the set A only. And here, this light blue, right, will be the set B only. The orange in the middle here is the intersection between A and B. Everything shaded so far would be A union B, right? And on the outside would be A union B prime. Everything that's outside A and B, right? So we have a note here in the bottom of the question. A intersect B prime or composite is equal to A prime union B prime. We should have seen that in the notes that you had from the questions before. And similarly, A union B composite is equal to the intersection between the A composite and B composite. So these two sets will also be equal. I believe this is upside down, but I'll have to check it back with the notes.